Welcome back, ladies and gentlemen, to another video with Mr. Kenton for HL Chemistry. Hope you guys are doing well today. I'm excited about what we're going to take a look at. We're going to be looking at empirical formula and molecular formula today. And again, here's our understanding. Here's the key thing that as we look at this content, as we look at these notes, that I'm wanting you to be able to take away from watching this, right? So the empirical formula and the molecular formula of a compound give the simplest ratio for the empirical formula and the actual number of atoms present in a molecule, respectively, in a molecular formula. And remember, those pieces of information are vital. They give us different things that can help us determining identities of substances moving forward. And so as we begin to take a look at this, let's start first with empirical formula, that simplest ratio of the atoms that are present in our compound. So here we go. Let's dive in. So remember, by definition, the empirical formula is the simplest whole number ratio of the atoms that your formula contains. So this would be taking the formula that you have and simplifying it to the lowest whole number ratios, right? So if you had something like C6H6, for example, that would simplify and it would go to CH. That would be the empirical formula for C6H6, which happens to be benzene. It would be CH. Now, your molecular formula, it is some whole number multiple of your empirical formula that's going to show you the actual number of atoms of each element that are present in that particular formula or in that particular compound. Now, again, obviously, the molecular formula is going to be much more useful in determining the actual identity of the substance, getting that molecular formula showing you exactly how many atoms of each element that you have. But the empirical formula is going to give you a quick glance at the percentage by mass of each substance that's present, right? And so having each of those pieces of information can be useful in their own regard. And so, again, we're going to focus right now, as we're shifting here, towards that empirical formula first. So what we need to be able to do to figure out empirical formula is that when we're given percent composition by mass or percentages by mass of elements that are in a compound, we should know how to tackle that and convert it over into a meaningful way so that we can determine the empirical formula. So if you think about it, I'm just going to give you guys kind of the rundown, the process which we use in order to determine the empirical formula. So the first thing that we're going to need to do is find the percent composition of the elements that make up of our compound. Now, a lot of times, that information is going to be provided directly to you in the context of the problem that you're given. Our second task is, once we've determined that percent composition, because percentages add up to 100, what we're going to do is we're going to take those percentages, we're going to assume it's a 100-gram sample, and we're going to convert those percentages to the gram values of each of those individual substances that are present in our compound. The third thing that we're going to do is we're going to take those gram values that we now have, and we're going to use the molar mass conversion factor to get us to moles. And so we'll be dividing by the molar mass so we can take each of those substances to moles. The fourth thing that we're going to do is we're going to divide all of our mole quantities once we get them from step 3. We're going to divide by the smallest number of moles found in step 3 in order to try to find out whole numbers that we have within our given formula. And then lastly, let's say that you divide everything by your smallest quantity and your numbers aren't whole numbers, then you're going to need to multiply by some factor in order to make those numbers whole. Now, if you recall, the types of numbers that you're going to see there should be something like 0.25, 0.33, and 0.50. Those are going to be the most common non-whole numbers that you're going to get, or maybe 0.2. But something like that, because then we could know that we would need to multiply by, if it's 0.2, we'd multiply by 5. If it's 0.25, we multiply by 4. If it's 0.33, we know we multiply by 3. If it's 0.5, we multiply by 2, so that we can make everything a whole number. And it's important for in step 5 that you multiply everything by that whole number, not just the thing that's not a whole number. All right. Now let's take a look at an example of what this might look like. So let's say that you're told that you have a hydrocarbon that contains 85.7% by mass of carbon. What is the empirical formula for this hydrocarbon? Now, you might be wondering, well, Mr. Kenton, it told me it's 85.7% mass by carbon, but it didn't give me the rest. Well, that's why understanding what a hydrocarbon is. Remember, hydrocarbons are compounds that contain carbon and hydrogen. So the remaining percentage by mass is probably hydrogen. So understanding that, our first step would be to get our percentages, right? So we know we've got 85.7% carbon. The remaining percentage should be hydrogen. So we've got 14.3% hydrogen that's left over. So that gets us to our 100% of our mass. So now that we have our percentages, we're going to take those percentages and just simply change them over to grams. We don't have to do any sort of funky conversion factor. We just simply take those percentages, make them gram values. So now we've got 85.7 grams of carbon, and we have 14.3 grams of hydrogen. So now we've completed step 2. Step 3 says we need to go to moles. All right. So in order to do that, we're going to take the gram values and divide them by their molar masses of those respective elements. So for carbon, we're going to take the 85.7 and we're going to divide it by 12.01 grams of carbon. And so we end up with 7.14 moles of carbon. For hydrogen, we take that 14.3, divide it by the 1.01, and we end up with 14.16 moles of hydrogen. All right, so we've completed steps 1, 2, and 3 at this point. We now have our mole values, so step 4 is going to tell us we need to divide by our smallest mole amount, which in this particular case is going to be the moles of carbon. That's our smallest mole amount. So in step 4, we divide by the smallest number of moles for each of those. So obviously 7.14 divided by itself is 1, and 14.16 divided by 7.14 is 1.98. Now this is one of those cases where that's close enough to 2 where we can just simply say, all right, that's 2, right? And so from that point, we didn't need to multiply by anything. So we don't have to worry about step 5. So that's the end of the problem. So now we have an empirical formula for our hydrocarbon, which is CH2. So the empirical formula for this hydrocarbon is CH2. Now I hope that makes sense. Obviously, feel free, if you need to pause the video, rewatch that so you can kind of re-familiarize yourself with calculating empirical formulas. Feel free to do that. But if you've got this and you're ready to move on, keep following along with me here, okay? All right, so the next thing we need to do, now that we understand how to determine an empirical formula, how would we determine the molecular formula of a compound? Well, the key thing here is we have to have the empirical formula, and we have to be given the molar mass of our molecular formula. Okay, and so it does give you a hint here. If you have to be given the experimental molar mass in order to solve a molecular formula problem. If they don't tell you the molar mass and they only give you the empirical formula, you're not going to be able to figure out the molecular formula of a compound. So just kind of know you need those 2 pieces of information in order to determine this. Right? So here are the steps, and then we'll look through a problem again together. So the rules for molecular formula. Step 1, solve for the empirical formula. Okay, so then you have to kind of think back, what did we do for the previous process? You may have to go through all of those steps in order to get the empirical formula, or they could be nice to you, and they could give it to you. They could tell you the empirical formula of the substance is insert empirical formula, right? So depending on what you're given, depends on how involved that task is going to be. So once you have the empirical formula, your next step is going to be finding the empirical molar mass. Now again, that's probably going to be embedded within the problem, and so they're probably going to tell you what the molar mass of it's going to be. Now you're going to use that molar mass that they've given you, and you're going to divide it by the empirical formula molar mass, right? And so the empirical formula you found in step 1, you're going to take, you've got the empirical molar mass that you found in step 2, so you're going to take step 2 divided by step 1, and this answer that you get should be a whole number when you're calculating molecular formulas at this particular case, right? And then, so once you get that whole number, you move on to step 4. You're going to multiply the empirical formula by the whole number that you found in step number 3 when you divided the molecular formula mass divided by the empirical formula mass. Excuse me. When you take the empirical formula mass I've confused myself. Sorry. When you take the molar mass of your molecular formula and you divide it by the empirical formula mass that you found. I hope that makes sense. If you have questions, ask me in class. I think you understand what I was trying to say. I just kind of tripped myself up. All right, so let's take a look at a sample problem. How would we go about doing this? So let's look at this question. The compound with the empirical formula CH2 is analyzed by a mass spectrometer and found to have a relative molecular mass of 42.09. Deduce its molecular formula. All right. Now, for this one, they were awfully nice to us. They gave us the empirical formula, so we don't have to go through the previous steps in order to find for empirical formula. That's nice. So step 1, get your empirical formula, which is CH2. Whew, that was hard work, right? Step 2, find the empirical formula molar mass. Take the mass of carbon and then add 1.01 times 2. That's where we get the 14.03 grams per mole. So we've got an empirical molar mass now. Step 3, they gave us the molecular mass of 42.09. We need to divide that by our empirical formula mass that we just calculated in step 2. So 42.09 divided by 14.03 is very conveniently 3. So now we're going to multiply our empirical formula by the number found in step 3. So we're going to take CH2 and multiply all that by 3, which should give us C3H6, right? So our molecular formula for this particular compound would be C3H6. All right. Now, I hope that made sense. Hope that was clear for you. Hopefully this is a good reminder. Again, I know these are skills that we looked at in AP chemistry and in honors chemistry, but I want to make sure that we're all up to speed and that you've got an opportunity to kind of manipulate this stuff in your own time. So hopefully this was helpful. If you need to go back and look at anything, feel free to do so. But I appreciate you guys watching this, taking the time to do so. Make sure you complete the Google form that's going to be associated with this particular video. And I look forward to seeing you guys in class again soon. Take care, guys.